Okay, so here's your starter for 10. We're going to do some algebraic fraction stuff today, but first of all, you need to practice a skill that's essential for this, which is just simplifying ordinary fractions. So I want you to simplify these so they are fully simplified. That's what it says at the top there. Pause the video, unpause when you've done them all, please, and no calculators. So we have unpaused. Right, the first one, you could divide the top by 3 to get 1, and the bottom by 3 to get 4. So it's the same as a quarter. This one, now you could, if you notice this, you could divide this by 36, top and bottom, but maybe let's say you don't know that, you haven't noticed that. How about we divide the top by 12 to get 3, and the bottom by 12 to get 6, because 6 12s is 72. And then I can see that top and bottom could again both be divided by 3. 3 divided by 3 is 1. And 6 divided by 3 is 2. So it's the same as a half. Okay, so you can do it in steps if you want to. What about 2 divided by 25? Well, that doesn't simplify any further than it already is. Sometimes you just can't. If there's not a number that divides the top and the bottom, leaving a whole number obviously, then you can't do it. Right, this one, I think we can divide by 14. See, there are 2 14s in 28. That's a really bad 2, isn't it? And how many 14s go into 42? Well, it's 3. So that is the same as 2/3. Just double check, yeah. Right, 32 over 40. You can divide top and bottom by 8 to get 4 over 5. 9 over 42. You can divide them by 3. And the bottom divided by 3 is, well, we've just had that, isn't it? It's 14. So 3/14. 45 over 60. We can divide them both by 15. There are 3 15s in 45, and there are 4 15s in 60. Again, it doesn't matter if you do it in steps, as long as you end up eventually with the same fully simplified answer. Right, 72 over 90. 72, I think actually is, well, I'll tell you what, let's halve it first of all. That's 36 and that's 45. And I can see now these divide by 9, so that will be 4 over 5. 28 over 80 again. You know, sometimes if you're not really sure if they divide by 2, just divide them by 2. That gives you a good start. 14 over 40. Let's do that again. 7 over 20. And that's as simple as that one goes. 14 over 70. We can divide them by... let's see. Well, I'll tell you what. Let's divide by 2 first of all. 7 over 35. Ah, right. And then I can see I can divide both of these by 7 to get 1/5. And then 24 over 36. They both divide by 12. So there are 2 12s in 24 and 3 12s in 36. 26 over 169. I already spotted these. It divides by 13. There are 2 13s in 26, and 13 squared is 169, so that's 13 13s. So 2 over 13, 2/13, all right? I'm just going to double check that because, yeah, just make sure. 2/13, good stuff. Okay. So, algebraic fractions. We're going to look at simplifying. Now, an algebraic fraction is literally a fraction with some algebra in it. That's all it means. So, just like the fractions we had before, but with some algebra, like this one. So, 8x divided by 2. Now, I'm going to show you the long way of doing this, because I think it helps with the explanation. The ordinary numbers, you can just divide as you ordinarily would. Now, 8 and 2 both divide by 2, right? So, if I divide the 8 by 2... I get 4. If I divide the 2 by 2, I get 1. So I've now got 4x over 1, which is just 4x. Okay, so if you can divide each element by something, by the same thing, then you can do that to every element in your fraction. So this one, the 10 and the 15, both divide by 5. So I'm going to divide the 10 by 5 to get 2, and 15 by 5 to get 3. Now the top is now 2y, and the bottom is 3. All right, so just divide each element by the same thing. Now, if there's more than one element, you just need to check that all 3 bits or 4 bits, whatever it is, can divide by the same thing. Now, all 3 of these can divide by 2. So let's divide 12 by 2 to get 6. 6 will divide by 2 to get 3. And 20 will divide by 2 to get 10. So rewriting this now in its simpler form, 6 plus 3y over 10w. Okay, now the top bit could be factorised, and actually as a mathematician if I can factorise something, I usually like to, but we'll ignore that for now, we'll come to that later on. Okay, this one, got 3 elements here, all of which divide by 5, so let's do that. 20 divided by 5 is 4, 5 divided by 5 is 1, and 10 divided by 5 is 2. So I've now got 4a on top of my fraction, and underneath we have 1b squared. Well, I'm not going to write 1b squared, I'll just put b squared, plus 2. So 4a over b squared plus 2. Yeah, fair enough. Right, there you go. Nice and easy start to the day. Pause the video, have a go through those, and unpause when you is done. You have done. I've unpaused, and I had a slurp of my diet caffeine-free Coke. Right, both of these divide by 6. There are 3 6s in 18, and 6 divided by 6 is 1. So this simplifies to 3y. I don't put 3y over 1, because anything divided by 1 is just itself, so it's just 3y. And both of these divide by 7. So 2 7s in 14, and 1 7 in 7. So the top of the fraction is 2, and the bottom is 1x. Well, I don't write 1x, I just write x. Both of these divide by 5. There's 1 5 in 5, and 7 5s in 35. Now the top again is 1x, so we just write x, and the bottom is 7y. And we've got 3 elements here, but it's all right because they all divide by 2. I don't think... Oh, no, hang on. No, we can divide them by 4, actually. So there are 7 4s in 28. And there are 2 4s in 8. And again, 2 4s in 8 down here. So, rewriting this, we've now got 7y plus 2 all over 2x cubed. Yeah, pretty straightforward, isn't it? Right, all of these divide by 5. There's 1 5 in 5, 3 5s in 15, and 2 5s in 10. Now the top of the fraction is 1. This time I do need the 1, because otherwise there would be nothing on top of my fraction, and that would be ridiculous. Can't do that, obviously. But the bottom is 3a plus 2b. That's the only downside of writing, sort of crossing these out. I like this method of crossing them out and replacing them with what you've found after you've simplified, after you've divided. But the only problem is you've got to be careful you don't accidentally draw over something that you miss one of the letters or something. Okay, right, so let's make it a little bit harder each time. So again, there's a fraction with algebra in it. Algebra. Fully simplify each fraction. Okay, numbers here are easy. Let's divide 5 and 25 by 5. Now there's 1 5 in 5, and there are 5 5s in 25. So the top of my fraction could be written as 1pq, or rather pq. And the bottom of my fraction is now 5p. Right, now here's the thing. I've actually got 2 things that cancel out here. I've got pq, so that's p times q, and 5p, that's 5 times p. I can actually divide p by p. If I divide these, they cancel out. Right? I've got p divided by p, that just disappears. Or if you really want to think about it the long way, if I do p divided by p, I get 1. And if I do p divided by p, I get 1. Now 1q is just q, and 5 times 1 is 5. Now make sure you're not adding here, because this is 5p, 5 times p. But I divided that to get 5 times 1. The shorter version is that if you've got a letter on top and underneath, but in every element, there's only 2 elements here, top and bottom, they cancel each other out. Let's try it again. Right, 4 and 2. Well, the numbers, divide those by 2. So there are 2 2s in 4, and there's 1 2 in 2. But I've also got some x's here that cancel out. That x cancels out that x. So on top, all that's left is the 2 and 1y. Well, I don't write 1y, I just write y. Okay, 18abc over 12bc. Right, 12 and 18 both divide by 6. So I've got 3 over 2. I've got a b on top and a b underneath, so they will cancel each other out, which leaves 3ac. Oh, hang on, I didn't spot the c, did I? Look, yeah, you're probably going, oh, you missed the c, idiot. C cancels out the other c. So that c is gone as well, actually. All that's left on top is 3a. And underneath, pretty much everything's gone except for a 2. Right, 30x cubed over 4x. Right. Okay. 30 and 4. Well, they both divide by 2. There are 2 15s in 30, and there are 2 2s in 4. Then I've got x cubed and x. Now that x underneath, remember that it's really just x to the power of 1, isn't it? There's only one of them. Well, that 1x will cancel out one of the x's on top. So it's no longer going to be x cubed anymore. On top, it will now be x squared. Now that x doesn't cancel out all the x's, it only cancels out one of them. And if it's x cubed on top originally, there are 3. We've got rid of one of them to leave 2. So x squared. Underneath, it's just 2. Now, if you're not sure about that, rewind and listen to that explanation again. Otherwise, there's some for you to have a go at. All right. Now, if you divide, one particular bit, one element, like where you've got 3 elements here, you need to divide all 3 elements by the same thing, or things won't cancel out. Okay. Anyway, pause the video, have a go through those. Unpause when you're done. Okay, unpaused. Nice. Right, 24 over 18. Divide those by 6. There are 6 4s in 24. And there are 6 3s in 18. Okay, but then I've got a y on top and a y underneath that cancel each other out. So the top has 4x, and underneath we have 3. 32 and 8. Both of those divide by 8, and there are 4 8s in 32 and 1 8 in 8. I've then got an x on top and underneath, they cancel out. And a z on top and underneath, they cancel out. To leave 4 over 1y, which is just written as y. 5 and 35, I think we can see they both divide by 5. There's 1 5 and 5, 7 5s in 35. Then I've got x to the power of 4 and x underneath. Now remember, that's x to the power of 1 really. And that 1x cancels out one of the x's on top. So it's now x cubed. So I've got 1x cubed. And 7, well, it's just 7, isn't it, underneath? Nothing else. Poor little 7. And 28 xy squared over 8xy. Okay, lots going on here. 28 and 8. Both of those divide by 4. And there are 7 4s in 28 and 2 4s in 8. I've got an x on top and underneath, so they cancel out. And I've got a y squared and a y underneath. Now that y, remember, is y to the power of 1. So it cancels out one of the y's on top. So that's now y to the power of 1 as well. 7y to the power of 1 is just 7y. We don't put power of 1, do we? That's only whilst we're thinking. Underneath, 2 and everything else has disappeared. Now this one, you've got to be careful with this one. The numbers are easy because all of them divide by 2 to leave 2, 3 and 4. Then I've got x squared, x cubed and x to the power of 1. Now, I've got to divide all 3 parts by the same thing for it to work, right? So this 1x underneath, I'm actually going to, it doesn't cancel out one of the ones on top. What it actually does, what we're really doing is going, right, I'm going to divide x squared by x to leave just 1x, x to the power of 1. I'm going to divide x cubed by x to leave x squared. And x to the power of 1 divided by x just leaves 1, doesn't it? 4 times 1 is just 4. So on top, I've now got 2x squared. No, sorry, not x squared, is it? 2x to the power of 1, so just 2x. Sorry. Plus 3x squared. So that's important, that one. Now, as a mathematician, actually, I probably wouldn't deal with it this way in future. I'd probably factorise it first, but that's coming up further down the line. So we'll, you know, if you got that one wrong, don't feel really bad. Loads of people get that wrong because they're not kind of following the rules really tightly. Okay, the last one here. All right, 10, 5, and 15 all divide by 5. So 2 5s and 10, 1 5 and 5, 3 5s and 15. Now, you can see that two of these things have an x on. Now, they're not going to cancel each other out because I could divide 15x by x and 10x I could divide by x. But 5y I can't divide by x. Although I can, but it's not going to simplify things. It's going to make things worse. So actually, this one, I can't cancel any of the letters. All I can do is rewrite the top as 2x plus y all over 3x. I can only divide the numbers. Every element in there must have that letter in it or number in it to be able to deal with it. All right. So what have we got next? Okay, just some slightly harder ones then. Right, so this time, 8 and 2, they both divide by 2. There are 4 2s in 8, and 1 2 in 2. I've got x cubed and x to the power of 6. Right, that x cubed is going to cancel out 3 of those x's on top. There were 6. So now we, 6 times together it is. Now there's only going to be 3 x's times together. The y's, okay, now the smaller amount is actually on top here, so they are going to cancel out, all 4 of them will cancel out 4 of those y's underneath, meaning it's now y squared. We're actually kind of using our index laws here, really. So the top is now 4x, and that's a 3, isn't it, left over there, all over 1 y squared, so one lot of y squared, which we just write as y squared. Right, 21 over 7. Well, they can't divide by 7 to give 3 and 1. I've got a to the power of 9, a to the power of 12. Well, the smaller amount's on top, and those 9 are going to cancel out 9 of those a's multiplied together underneath, which will leave, what's the difference between 12 and 9? That's 3. So that's now a cubed. I've got b to the power of 5 and just a b here. Now that's b to the power of 1, isn't it? And that b will cancel out one of the b's on top. So it's now b to the power of 4. So what have we got left? 3b to the power of 4. And 1a cubed, which we just write as a cubed. Then 5 over 15. Okay, both of those divide by 3. So 3, what am I talking about? By 5. 5 divided by 5 is 1. 15 divided by 5 is 3. X to the power of 4 and x7. So the smaller amount is on top. So those 4 x's multiplied together will cancel out I'm thinking ahead. Will cancel out 4 of the ones underneath. So I've got x to the power of 4 on top. That will cancel out 4 of the ones underneath, leaving x cubed. Then I've got y to the power of 8 and y squared. Now that y squared, the smaller amount, will cancel out 2 of the y's on top, which will leave 6 of them. So I've got 1 y to the power of 6, which we just write as y to the power of 6, and 3x cubed. Just think of each section on its own, individually, the numbers, and then each letter individually. Okay. 3 to have a go at. I'll probably go a bit quicker through the answers for those, so hope you're all right with that. Pause. Remember to write the questions down as well. Very important. And unpause when you're done. Okay, right. The 9s we can divide by 3. 9 and 3 can divide by 3, sorry. So 3 and 1. X's will cancel out 2 of the x's on top to leave x to the power of 7, that's supposed to be. And the y's will cancel out 11 of those y's underneath to get y squared. So, on top, 3x to the power of 7 all over 1y squared, which is just y squared. These will divide by 6. So 6 divided by 6 is 1. 18 divided by 6 is 3. The a's, those 4 a's on top will cancel out 4 of the ones underneath to leave a to the power of 6. The b's, well, those 3 b's will cancel out 3 of the ones on top to leave b to the power of 5. So 1 b to the power of 5, which is just b to the power of 5, all over 3a to the power of 6. Last one. 20 and 4 both divide by 4. So we'll have 5 and 1. The x's will cancel out. Those 6 will cancel out 6 of the ones on top to leave a squared. And y to the power of 5, y to the power of 7. Well, those 5 on top will cancel out 5 of the ones underneath to also leave y squared. So on top, it's now 5x squared all over 1y squared, which is just y squared. Okay, that's enough of me yabbering on. You can go over to Dr. Frost to go and do some questions on that. Off your trot.